Welcome to Bureau Veritas's Q&A webinar called Pfas Analysis, Choices, Challenges, and Answers. I'm your moderator, Quinn Smith. In today's session, we'll answer your commonly asked questions, the ones that we receive from our customers, the ones that we receive while we're at conferences, as well as ones that have been submitted by you, our audience. Bureau Veritas is the global leader in testing, inspection, and certification. Our mission is to shape a world of trust by reducing clients' risks, improving their performance, and helping them innovate to meet the challenges of quality, health and safety, environmental protection, and social responsibility. Today, I'm joined by my esteemed colleagues, Dr. Terry Obal, Dr. Heather Lord, and Stephanie Paulin. I'd like them to introduce themselves. So Terry, why don't you take it away?
Great, thank you, Quinn, and good afternoon, everybody. My name is Terry Obal. My role is Chief Science Advisor for Bureau Veritas's Environmental Laboratories and Specialty Services, and it's quite a dynamic and multifaceted role in that I get involved providing input on new technologies, evaluating emerging markets, helping to commercialize testing to support those emerging markets, providing input on research and development activities, primarily technical support, and this is often project-specific technical support, as well as getting involved in litigation. So essentially, my role is to make sure that that science and good science and its value are available to our staff, to our customers, and to the public.
Thanks, Terry. Really appreciate that. Heather, can you introduce yourself as well?
Oh, yeah. My name is Heather Lord, and I'm the Manager of Environmental Research and Development. So once a project has been defined, I will manage the teams that bring that to market. And generally, we work on projects that look to bring innovations to our clients, things that will improve remedial capabilities, reduce cost, and improve environmental support for monitoring.
Thanks, Heather. And finally, last on our panel is Stephanie Paulin.
Thanks, Gwen. My name is Stephanie Paulin. I am our Technical Account Manager for Pfas and High-Res in North America. I've been in the environmental lab industry for just about 6 years now, starting in project management and then transitioning over to account management. And my primary role is working with and supporting our new and existing clients and ensuring project success from start to finish.
Thanks, Stephanie. I appreciate it. Well, today's session is going to be interesting. These are the questions, as I said, have been submitted by our customers that we receive, or the common questions that we get when we're at conferences, and the ones that have been submitted by the audience. I don't want to go into too much depth about the background of PFAS. Most of the people that are going to be on or are participating today likely know the detail behind PFAS and the history of PFAS, starting in the 40s and 50s, etc. But I think it's important that we do give just a little bit of context. So I'm going to ask Terry to field this question. Where did PFAS come from, and why is there such interest in its environmental impact?
Great, thanks, Quinn. Where did PFAS come from? PFAS is, it's referred to as an emerging contaminant. But really, it's an emerging contaminant of environmental concern. PFAS has been around for easily 70, 80 years, being first discovered in the late 30s, and then really put into commercial production in the 50s. And then it improved our quality of life. It allowed the manufacture of non-stick cookware, so your eggs didn't stick to your fry pans. It gave a certain physical property to different formulations of oils and lubricants, but primarily it repels water, it repels oil. So it was used in those kind of consumer products. But one of the primary sources of PFAS in the environment is going to be the aqueous film-forming foams. These are the firefighting foams that had percent levels of PFAS introduced. Why? One of the advantages of PFAS is its stability. It has set a new bar for persistence in the environment. So its benefit of stability is also the negative when it comes to environmental contamination. It doesn't break down. So they used it in these firefighting foams because it was very effective at smothering the fire. The compounds wouldn't break down. So so that's where it came from. Why the environmental concern? The use of PFAS, which is the acronym for per and polyfluoroalkyl substances. It's a group of compounds that is numbering over 5,000 compounds. Its prolific use over the course of the last 60, 70 years, when it was commercialized, really has created a bit of a problem. It is everywhere. It's ubiquitous. And the fact that it is so persistent in the environment, it is not breaking down, not readily. And as a result, it's been glamorized somewhat, being termed forever chemicals. And, the inference is that it'll be around forever. And recent toxicological studies or toxicity studies are suggesting that there is a negative human health effect related to this class of compounds. So because it's everywhere, there is the potential for human toxicity, and it's persistent. If you subscribe to the environmental precautionary principle, or at least my environmental precautionary principle, it's persistent, it bioaccumulates, and it is looking to be toxic. We need to be looking at it. We need to be addressing it as an environmental concern.
Yeah, and later there's some questions later on as we go down the list. It talks about where are the concerns. They started really in the contaminated soil, contaminated water, groundwater, surface water, drinking water, of course. But I think that's expanding now, and we'll talk a little bit more about that as we go forward. The next question that was submitted, and I'm going to ask Heather to tackle this one, and it's pretty basic to chemicals, which is, what is a CAS number, and why does PFAS have multiple CAS numbers?
Yes, that's a good question. It does cause a lot of confusion, certainly. So a CAS number, CAS is an acronym for Chemical Abstract Services. And this is a group of volunteers that started out in the early 1900s to start recording all of the new chemicals that were being developed. And as a new chemical was developed, it was submitted to a group of scientists. It was given a chemically appropriate name, an accepted chemical name, and then they assigned it a number. And literally a CAS number is the number that this group of scientists started assigning to chemicals in the early 1900s. In the mid-50s, the Chemical Abstract Service was taken over by the American Chemical Society. So it's no longer a volunteer organization. It's now a group of the American Chemical Society. But that's what they're continuing to do. They monitor when new chemicals come on the market. They give it an accepted chemical name, and then they assign it a CAS number. And these numbers are now used worldwide to identify the exact structure of a chemical with an identified chemical name. The reason there's so many associated with PFAS, for instance, PFOA, one of the compounds that's seen a lot of media interest, has 3 or 4 Chemical Abstract Services names. This is because many of the PFAS are partially charged. That is, they act like an acid. So in its acid, so-called acid form, it's given one name. But if it's in its salt form, it's going to be given a name similar to that salt. So take the concept of sodium chloride. We all know sodium chloride, but there's also calcium chloride. There's potassium chloride. So just because it's a chloride doesn't mean it has all the same CAS number. There's different CAS numbers for calcium chloride, potassium chloride, sodium chloride. Same thing for PFOA. In its acid form, it's called the octanoic acid, but in its salt form, it might be sodium and then octanoic acid. There's a potassium form, potassium such and such octanoic acid. There's an ammonium form, So there's different CAS numbers for the same compound because they can exist either as their acid or as a salt form. It does create confusion, I know, but that's the way the CAS works. Everything has to have a specific CAS number based on the chemical structure. And because PFAS have different forms, whether they're in their salt form or their acid form, they'll get different numbers. But in the environment, they all behave the same way. All the different versions of PFOA, whether they're acid or salt, all behave identically. And therefore, it does add confusion to, for instance, reports that come out from labs such as ours, and regulations too. Different regulations typically will quote a CAS number in terms of deciding what exactly the chemical is that's being regulated. But if the regulations only pick one of those 4 or 5 CAS numbers for PFOA, then people trying to follow the regulations get confused.
Okay, thank you. Great explanation. I'm going to switch it up a little bit here. A lot of the questions that came in, are a healthy chunk of the questions that came in, were around regulatory trends. And we're going to kind of span the globe a little bit here. And we know that country to country, state to state, province to province, the governments and the regulators have varying degrees of maturity in their process of regulation, how they're regulating, their philosophies on regulation, and also for how to sample for a wide variety of PFAS. So let's start in Canada, and we'll talk a little bit about where that's going. So in my opinion, I believe Canada is lagging behind a little bit in regulation. That is my opinion. For example, in British Columbia, the province of British Columbia, they're regulating 3 compounds. Health Canada has established guideline values. But Terry, can you help me out a little bit here? Walk us through where PFAS regulation is going in Canada, or where do you think it's going in Canada?
Sure. You're right. I think from an optics perspective, yes, Canada is lagging behind, but recognize that Canada did not manufacture PFAS per se, at least that we're aware of. So the situation is somewhat different, but the sources of PFAS impact in Canada are primarily from products manufactured with different PFAS formulations. So these are the third-party manufacturers. Things like PFAS containing firefighting foams, these AFFFs that I referred to earlier. The discharge from wastewater treatment plants, or more so, the biosolids from the wastewater treatment plants where these compounds tend to accumulate. So there are definitely sources of PFAS impact in the environment. So it needs to be regulated. And in fact, the Canadian government back in 2013 started regulating AFFFs. The Canadian government banned the use, sale, and manufacture of aqueous film-forming foams, the AFFFs, containing more than 0.5 part per million of PFAS. Now recognize that 0.5 part per million is 0.5 part per million. To put it into perspective, the AFFFs typically contain percent levels. So 0.5 part per million it's basically 5/100,000th of a percent. So 0.00005%. But I'd note that the federal government doesn't necessarily regulate contaminants, at least not on property that's not federally owned or federally run, but rather they issue guidance values for specific compounds identified through instruments like the Canadian Environmental Protection Act or the Chemicals Management Plan. So, and then each province, through provincial legislation, will either adopt the federal guidance values as regulated standards through provincial regulations, or they'll establish their own, but based on the federal guidance. So I think that's where we are now, with the exception of British Columbia and outside of specific directors' orders from various ministries to clean up a contaminated property. I think the provinces are looking to the federal government for direction on regulatory standards.
Okay. Yeah, and interesting to me in that, as Heather, I think you made mention of it earlier, or Terry, maybe it was Terry, I'm not sure, but there's more than 5,000 PFAS compounds. So I'm curious, is it on the table to regulate PFAS as a class as opposed to specific compounds? Do you think that's on the table?
Yeah, in April, actually, in April of this year, the Canadian federal government posted a notice of intent to address PFAS as a class of compounds. But what's contained in this notice it's the move by the federal government to study this option through continued monitoring of individual compounds in the environment, more human toxicity studies and material information with respect to human health risk and stakeholder input, and then issue a report of their findings within 2 years. So not to read too much into this notice of intent, but the wording is to address PFAS as a class of compounds, not necessarily regulate. But having said this, and depending on the results of their study, I would infer that regulation, or at a minimum public guidance, is forthcoming and will result from this.
Okay, great. Well, and the manufacturing or industrial hub of Canada is centralized around Ontario. Where's Ontario in the progress with regulation? Have they made any?
The province of Ontario, they have been monitoring PFAS for a long time, and they're an example of a province that I think right now they're waiting for guidance from the federal government. Certainly, the Health Canada has published the guidance values for drinking water, but they haven't made a move on regulating these compounds. But like I say, having said this, there have been orders from the Ministry of the Environment, Conservation and Parks in Ontario, the MECP, for certain sites to clean up PFAS to a certain standard. And it's a little bit different from some of the other jurisdictions, where rather than looking at just perfluorooctanoic acid and perfluorooctane sulfonic acid, PFAS and PFOA, they're looking at 11 compounds, and the sum of which cannot exceed 70 parts per trillion, which it's very difficult, very challenging with current technology.
Right. So let's change it up too, and thanks for that. Let's go into the U.S. a little bit. So the U.S. EPA has established a lifetime, dovetailing into the 70 parts per billion, or trillion, excuse me. The U.S. EPA has also established a lifetime health advisory level of 70 parts per trillion. But we also know there's a variety of drinking water. If you look at by state, so that's the U.S. EPA, but if you look by state, there's a variety of drinking water screening levels, or drinking water standards, health advisory levels, or ambient groundwater standards. Where do you think the regulatory landscape is going in the United States? Heather, maybe you can tackle this. Where do you think it's going? Are we going to see consolidation? Are we going to see more consistency? Or is it still going to be overreaching US EPA and then state-driven?
I'm hopeful that at some point in the not too distant future, the US EPA will come out with a guideline, something like Health Canada or the Canadian federal government. But then I think actual regulation will continue to be state by state. Now, that's my suspicion at the moment. But I do think it's also going to go lower. I think as new publicly available toxicity information comes out, and as something called sort of risk values for different PFAS come out, and there's greater certainty around the toxic consequences of PFAS. I think when those come out and they're published and accepted, I think that will drive the regulations lower and lower, because the preliminary data that we're seeing from fairly reputable organizations is showing very low concentrations can cause somewhat concerning, typically long-term health consequences. So yeah, I think probably state-led for regulation and generally going lower from where they are now.
Okay, thanks for that.
And Quinn, I'll add to that. Part of what's driving this lower and lower and lower is the analytical technology.
Right.
As technology with higher sensitivity, which translates into increasingly low detection limits, is developed, then I believe that the standards are also going to be driven somewhat by the technology. So that like when you have jurisdictions regulating at 13, 14 parts per trillion, I use time as the analogy. That's 13 or 14 seconds out of 32,000 years. So it really is an analytical challenge and a technological challenge. And so there you go.
And that's one of the questions that was also asked is, do you think technology contributes to the variability in the state limits? Do you think that, because there's a lot of variability, right?
I think I might phrase it a little bit differently, that there's variability in state limits. I think some of them are driven by the suggestions coming out of the toxicity laboratories and compounded with the trace level sensitivities of the technologies. But I think that just some states are, you used Canada as the example that we're lagging behind. Some states have established limits, and in some cases it's they're down at the low parts per trillion. Why? Well, because we can. And other states are they're just catching up. They need time to get caught up. Some
have none, right?
Yes.
Right. It's not. I mean, I haven't done a count, but I believe it's 10 or less right now that are formally regulated by state. Anyway, I have to look back at my data. Hey, Stephanie, I'm going to bring you into the loop on a question here, and I hate to put you on the spot, but so we just talked about variability in the regulatory standards, and from the lab perspective, from an account manager perspective, from a project manager standpoint, what challenges does that pose for the lab with the amount of variability, state to state, province to province, country to country, continent to continent? What does that do?
Yeah, it's difficult, right? When it is different, kind of based on every state, and that's the importance of the laboratory and the project management team to kind of understand the requirements for the project and to make sure upon project startup that we're on track and we know what's needed. Right.
And I think that's keeping track of the certifications and the updates that are required. I'm going to say it's almost a full-time job. I believe it is a full-time job. But yeah, there's a lot. It does add a lot of complexity into the laboratory. Are there any thoughts on that?
Yes. The other major area of complexity is our accreditation. Of course, to keep up our rigorous standards, we need to maintain our accreditation in any jurisdiction where we are offering services. And so I know our QA team spends a lot of energy to make sure that those accreditations are maintained across the whole area that we provide analytical services, every state and every province. And whether it's for food testing or product testing or environmental sample testing, it is a challenge to make sure all of those accreditations are in place, but it's so critical for our clients to have the confidence to know that we have those accreditations, that our results will be accepted by the regulators that they're showing them to. Yes, it's definitely worth the effort, but yeah, we spend a lot of time on getting this right.
Absolutely.
And Quinn, I'll add to Stephanie's point about the variability in the regulatory standards and the accreditation process. From the standpoint of the practitioner and interpreting results, there's always a caveat associated with regulating chemicals at or near the limits of detection of the analytical technology. It's measurement uncertainty or the plus minus value around the measured value, and it's inherent in all analyses. So as you get lower and lower and approaching limits of detection, that variability is very high. So if you have a regulatory standard of 5 parts per trillion and the uncertainty around a measured or a reported value of 7 parts per trillion is plus or minus 5, is it an exceedance of the standard? And this is something that the practitioner needs to have at the back of their mind if they're evaluating remedial options, or if they're trying to determine compliance or site closure, or the cleanliness, the cleanness of a groundwater system. From the regulatory body standpoint, the number is the number. But as a practitioner, if you're making decisions based on those really low levels, you need to have an understanding of the variability around those levels, particularly if the standard is, like I say, at or near the detection limit. And this is where engage the laboratory. Engage the laboratory where we can help you navigate measurement uncertainty at really low levels.
Yeah, it's great to have resources to be able to assist in that way. Stephanie, I'm sure you'd agree, when you're a project manager, now an account manager, it's incredibly helpful to have people like Terry and Heather, amongst others, to be able to assist in that regard when some of those challenging technical questions come in. That's fantastic. I'm going to ask a specific question now, and this was, I wanted to make sure we got to this one because, this first time I've heard this one. And it's, when will they start regulating commercial laundry discharge in the US? Any thoughts on that? I haven't heard anything, so I'm going to throw that out to the group.
Is it for PFAS or just in general?
For PFAS.
Yeah, because the PFAS, and Heather can speak better to this based on some of the information she garnered from a recent conference. But discharges to surface water systems are a known and possibly an important source of PFAS. Now, where is that coming from? Is it coming from, the commercial laundry discharge? It's been suggested that PFAS is in certain detergents, or is it coming out of the fabrics that are being laundered? I'm not aware of states looking at it at that granularity. But in terms of the wastewater treatment plants that are treating the industrial discharge and then discharging to a surface water system, I see that coming sooner rather than the individual laundries.
Right.
But Heather, you can speak more to that, I think.
Yeah, and yes, you're right. There was a fairly influential paper that came out earlier this year that suggested that wastewater treatment plant effluent is the major source globally of PFAS to the environment. And certainly cleaning products in general, laundry detergents have been identified as one of the sources of PFAS going into wastewater. And of course, we know wastewater treatment plants do not remove PFAS from wastewater. So yeah, I do see a lot of growing interest in regulating wastewater streams. And I think in most jurisdictions, if you're a large manufacturer, you can actually get regulations requiring you to monitor your own wastewater discharge, as well as municipal monitoring of general wastewater going into a wastewater treatment plant. So I think both of these things will increase as we see some regulations come in for PFAS. And yeah, I do suspect that wastewater streams will be one of the sources that receives a lot of attention.
Agreed. Thanks, Heather. Interesting question that just came in too. Are PFAS-free AFFF products available? Anybody want to tackle that one? So is PFAS-free alternatives, are non-PFAS alternatives to AFFF available on the market? Excuse me, there we go.
Yeah, I can provide some commentary there. Yeah. There is certainly a lot of interest in coming up with an AFFF that is effective and does not contain PFAS. Now, of course, there is a conundrum here. In analytical chemistry, in any lab testing, you can never say zero because there is things like uncertainty and detection limits. We can only detect down to a certain level, and all numbers have some uncertainty around them. So what the regulations will really, I suspect, be saying is you can't have PFAS in AFFF over X parts per billion, parts per trillion, something. So yes, there is a drive to get a really low number on the amount of allowable PFAS in AFFF. And certainly we've seen clients wanting us to tell them whether their AFFF that a manufacturer is suggesting is very low PFAS is actually that. And I can tell you, I have seen some successes. Sometimes an AFFF will come in that is screaming hot. The fire department or municipality or distributor thinks it's PFAS free, but it's not. So unfortunately, we get to give them that bad news. But more recently, we've seen some PFAS AFFF come in that is very low, orders of magnitude lower than your 3%, 5% level that is typical of a conventional AFFF. And actually, we've been monitoring these by both our standard PFAS analysis that reports 20, 30, 40 individual PFAS, as well as our newer total organofluorine test. And by both measures, some of the newer generation AFFF are very low in both PFAS and total organofluorine. So it's very encouraging. Now, I can only say from the lab point of view, yes, we can see really low numbers coming out now. Whether they work really well to put out a major fire at an airport, I think remains to be seen.
Right. That's not for us to interpret. That's for the that's for the fire department, for fire professionals to interpret. And that it's funny. I remember reading a report. I think it was I can't remember the timing, in 2019. It was reported that there were more than 100 fluorine-free foams available on the market, and that term PFAS-free is always intriguing. And you commented on that, Heather. So thanks for that. I'm going to ask a question. So I'm going to jump in here. I want to ask a question because we talked about this, Heather. So I'm putting up my hand and I'm going to ask a question now. So you recently attended the CTAC conference in Europe. And I know that you found it very eye-opening and you shared a bunch of that information with us. So I thought it was important that we shared this with the group. What stood out and caught your attention? And I also want you to comment on P-sufficient values. So can you give me a little bit of an overview there?
Yeah, actually, the discussion about the P-sufficient approach to monitoring and regulating PFAS in the environment was a major theme of the conference. Most environmental regulation up to date, it started to come in the 70s, has been based on toxicity of the chemical that's being regulated. However, the P-sufficient approach takes a different angle. It looks at the persistence of a chemical or a class of chemicals and proposes regulation based on their persistence alone, regardless of whether they are bioaccumulative or toxic. And because of the difficulty in determining things like bioaccumulation potential and toxicity of thousands of different individual PFAS, there's a lot of discussion in Europe about regulating PFAS as a class based on the known persistence of the class. And this is simply based on that really strong carbon-fluorine bond. And we wouldn't then have to look at all 5, 6, 7, 10,000 PFAS individually because we know they're all extremely persistent. Interestingly, California has recently proposed something like a PFAS sufficient approach to regulation of PFAS in that state. And Vermont may be moving towards that as well. They've recently brought in new legislation. They don't use the term P-sufficient, but the verbiage kind of talks that way. So yes, it's definitely a lot of talk in Europe, and it looks like now they're maybe moving to North America, this concept of regulation as well.
Okay, well, look forward to seeing where we go with that. That's very interesting for what's happening, again, in the regulatory landscape in North America. Terry, I want to ask you this question because I know you have you have quite a few connections within this space as well. But I want to ask you around landfills. And the question was, you would think that landfills would be a high potential source for PFAS contamination. How are landfills handling it?
How are landfills handling? They're playing their cards very close to their chest.
Sure.
I can tell you that the waste management companies, the operators of landfills, are all over this because there is the concern that that PFAS may be leaching out of the waste, and depending on the protective measures that were introduced when building the landfill, there's the potential of impacting groundwater systems. So the waste management companies, the landfill operators are very interested in remediation options, ideally treatment options where you're not simply repackaging the contaminants into a much more manageable form, but you're actually destroying the PFAS. So right now they're settling with remedial options to treat the landfill leachate, and they're becoming a little bit more sensitive to what they're accepting into the landfill. So in the absence of any regulations, it's almost self-regulatory. But I can guarantee you, talking with a number of the large waste management companies across North America, they're all over this.
Right. Okay. Great to know. And agreed. It's an area that I think is going to get more focus over the next little while. But definitely playing their card, or keeping their cards close to the vest. Stephanie, I'm going to blend a couple questions here for you. Besides, typically a lot of the queries that have been received are around sampling in soil, groundwater, surface water, et cetera. Mm-hmm. And I know in recent times, and that's why I'm blending this question together, what else? So this is about, it's food regulated. How about textiles? So it's a whole bunch. People are asking, what other sources of PFAS are people wanting to test for right now? What's coming in? What are people asking about?
Yeah, we're definitely starting to see more and more requests for kind of the once non-routine matrices that are now becoming a little bit more routine as the demand is just kind of growing. So things like textiles and fabrics, we're analyzing components in underwear samples or artificial turf samples, requests for testing cow milk or manure. I mean, the list really goes on. And, I'm lucky to work with the technical experts like the Terry and the Heathers, and it's great to be able to have the discussion with the clients and figure out what the best approach is for those types of samples to really meet their objectives. So one of the things is, bringing total organic fluorine kind of online and adding it to the toolkit, in my opinion, it's really just opened another door in PFAS analysis. So I'll kind of let Heather take over on the top side as she's our expert and kind of let her comment on the future there.
Yeah, it's interesting that there's that many, how it's changing and adapting. I mean, we know that, you've seen a number of companies, ban PFAS in food packaging, and you're starting to see this trend. I think you're going to see more and more of this. We're definitely hearing a lot more on textiles. I think, and this is, in my opinion, the IMO here, I think food isn't far off, but it's a little distance away, but I think that's in there too. And that does lead into the next question. And this is, for those on the line, this is a bit of a self-serving one, but I think it's important for a context. And when you have a variety of matrices, you need a variety of different tools or different methods of being able to analyze or provide the right data based on sampling objectives. So Terry, walk me through, and you have a presentation coming up on this, and this is the shameless plug that we've recorded. But talk to me a little bit about the use of analyzing or analyzing PFAS by LCM SMS versus TOPS versus TOP. Give me kind of a summary of what you use those for.
Basically, those are three key tools in the analytical toolbox. If you are PFAS by LCM SMS, is you're looking at individual compounds at levels that are at the low part per trillion, and in some cases the sub-part per trillion level for detectability. Total oxidizable precursors, or the TOPS assay, is a process that was developed out of the University of California in Berkeley. David Sedlak and Erica Hotz published a method, and it is for evaluating potential PFAS impact from compounds that are not target compounds, that are not part of the suite of compounds analyzed by Pfas, the Pfas by LCMSMS, and it's a little bit of a iterative process. Basically, it's been documented that higher molecular weight, the bigger PFAS compounds, some of the fluorotelomeres, can transform over time through biological mechanisms into the dead end products, the products of concern that are being evaluated by the regulatory bodies. So that's a group of PFAS that you're not testing for. So
right.
You know if it's there or not. And so in this case, you are doing PFAS by LCMS to get a baseline concentration. Then you are accelerating this transformation process in the laboratory by oxidizing the sample with a strong oxidant under elevated temperatures, and then quenching it, and then analyzing the PFAS, the target compounds again, and evaluating the changes. And if you start seeing increases, particularly in the lower molecular weight carboxylates, the perfluorobutane carboxylic acid, butanoic acid, the C5, C6, etc., then that means there is something else in your sample that you weren't measuring for in the first test. And you probably should be concerned about if you are executing a remedial action. And then finally, total organic fluorine is an approach to evaluating the total PFAS, or the total organofluorine burden on your sample or your site, where you're using fluorine as a proxy for PFAS, and not just fluorine, organic fluorine. So
right.
It's very important that you partition the inorganic fluorine, get rid of it out of your sample, and so that you're only left with the organic fluorine. And then that is combusted. One of the known and still the flavor of the month processes for treating PFAS is high temperature incineration, and these are temperatures of 1,000 to 1,100 degrees Celsius. What you would find in a waste incinerator that's operated by a particular entity. So what the lab is doing is they have a little incinerator that then mineralizes the PFAS and forms carbon and fluorine, and the fluorine is trapped, and you analyze it as fluoride. The differences are, one is expensive, one is twice as much because you're doing the analysis twice, and the total organic fluorine is it's a lot more facile. It's a little bit more of a pragmatic approach. It doesn't give you the detail that Pfas by LCMSMS or that the TOPS assay will give you, but it gives you more of a holistic picture for contamination. And then, there are strategies of using one analysis versus another versus a combination of them. One of the challenges with total organic fluorine, and Heather's lab is doing great work decreasing the detectabilities, the increasing the sensitivity, but decreasing the limit of detection, which is going to be important to have direct comparability with trace level contamination. But if you're remediating a site that is contaminated, use total organic fluorine. Keep using total organic fluorine until you get a non-detect. Don't stop. Then you have to migrate to a more sensitive analysis.
Right. That's fantastic. Thank you for that. And that tees up actually the next question. This is directly to Heather. So the question is, Heather, I saw your presentation on total organofluorine dark matter. Can you tell me how TOF by CIC compares to other methods like PIGI and neutron activation? Great question.
Sure. Great question. Yeah, those are the three leading approaches to getting a measure of total fluorine or total organofluorine. And as Terry mentioned, the only difference, whether you're getting total fluorine or total organic fluorine, is whether you do that pre-treatment up front to remove inorganic fluorine. For example, sodium fluoride. We all know sodium fluoride in our toothpaste. Sodium fluoride is very ubiquitous. And there are a few other inorganic fluorines that are around. They're natural. So we don't want an organic fluorine signal that we're attributing to PFAS to be contaminated by inorganic fluorine. So that upfront preparation is really key to turning a total fluorine measure to a total organic fluorine measure. And historically, the three approaches to getting a total fluorine, where you know you're getting all of the fluorine, not just smaller things, I should say, neutron activation, PIGI, or combustion ion chromatography. And there was a great paper that came out, I think it was within the last couple of years, out of Graham Beasley's lab, showing that neutron activation, PIGI, and combustion ion chromatography all give identical results in terms of total fluorine. So from there, it's just doing the upfront separation to remove inorganic fluorine and keep the organic fluorine, and then do the sample on that isolated, we call it extract. And whether you take that prepared extract and put it into a combustion ion chromatography furnace, a PIGI reactor, or a neutron activation reactor, you will get the same organic fluorine result. So that being said, all three processes are being looked at for both total fluorine and total organic fluorine. And the question now is, which one is going to be the leading contender for a reliable, widely applicable measure of total organofluorine? Combustion ion chromatography does have an advantage because it's very simple equipment, widely available because it's been used for decades for monitoring organohalides. And that does seem to be the leading contender that most regulatory jurisdictions, Europe, Australia, and North America in particular, are looking at for a widely available, inexpensive, fast turnaround assessment of total organofluorine.
Fantastic, thank you for that. And I'm gonna. This is a follow-up question that I'm just gonna ask, which what I hear, and when I'm talking to customers and when I'm at conferences and just talking to people within the industry, I don't think there's clarity yet on when to use total organic or total organofluorine testing with TOF. They're just not quite sure. So the question I have, and I'm actually taking this out of what somebody sent in, which is, does TOF play a role in risk assessment or just in regulatory compliance? What are your thoughts?
Me?
Yeah.
Yeah, definitely both. Certainly, regulators are looking at a total organofluorine or total PFAS measure or approach. Hasn't really been instituted yet, but definitely I see it coming in several jurisdictions. But also risk assessment. People doing ecological risk assessment are also looking at both a specific LCMS type detailed analysis where you know all the individual things in your sample, as well as a so-called non-targeted analysis, by which they mean getting a measure of all the PFAS there. And a paper came out earlier this year that was actually the outcome of a CTAC workshop from a couple years ago, where the suggestion is you need both. And the sort of non-targeted analysis, where you get a picture of all PFAS, they see that CIC would be their combustion ion chromatography would be the leading contender to provide that. One of the main benefits I see, particularly in ecological risk assessment, is, well, I refer to the dark matter in my talk.
Right.
And what I mean there is the excess organic fluorine that cannot be accounted for by all of the fluorine, all of the PFAS you measure in an LCMS-MS analysis. So if you take your standard report that's showing 20, 30, 40 PFAS by LCMS-MS, and you add them all up, and then you calculate how much organic fluorine that represents, then the TOF analysis can tell you how much additional fluorine, organic fluorine, there is in that sample above what can be accounted for by the LCMS-MS. And I'm calling this a TOF discrepancy, but I also think it's just easier to understand as the dark matter, the stuff we can't see. The TOF assay will tell us it's there. We don't necessarily know what it is, but it's definitely that discrepancy between your PFAS report and your TOF report. And that's what I'm seeing the ecological risk assessment wanting to understand is what's the excess dark matter that can contribute to toxicity that they don't have a good handle on at that point.
Terry, anything to add?
No, I agree with Heather. I think that's the direction, because you can't establish risk based exclusively on a parameter list or a target compound list of 40 compounds. You have to take into consideration impact from the, it was a term that was coined a while ago, I think by Andy Eaton, the unknown unknowns. Mm-hmm. So as Heather puts it, the dark matter, the challenge, and I think the toxicity, the toxicologists will agree, is how do you identify the toxicity of that dark matter? What is the impact? Is it a fraction of the individual compounds? So do we need to start looking at toxic equivalency factors similar to dioxins or the coplanar PCBs, or in some cases PAHs? IARC has a list of toxic equivalency factors. Do we incorporate the persistence of just PFAS in general, the P sufficiency? I think there's more to come there. I think there's potential value in that. But if you just establish risk based on one or two compounds that you have the most toxicity information on, I don't personally, I don't know if you're getting the whole picture.
Right. Okay. Thanks for that. I'm going to change it up again, and the next set of questions have been coming in, and I'm trying to blend them together a little bit. It's really around toxicology and human exposure, and I'm going to try to blend this one. And I think we've sort of answered it, but let's talk it through anyway. Where are the most significant exposures to PFAS? Where are humans exposed the most? Who wants that one?
Well, I'll let you
I know
go.
there was a paper that came out of France a couple of years ago that didn't really provide a definitive answer to that, but it suggested that people who live close to a freshwater environment where they would be eating a lot of freshwater fish do tend to have a signature of PFAS in their blood that is shown to be more closely related to the PFAS that accumulate in fish. Interestingly, there was one of the PFAS compounds, PFHXA, or the 6-carbon carboxylic acid, that was accumulating in the blood, and they didn't know the source. So they were able to identify that one thing about if you live close to a place where you eat freshwater fish, you'll have a
Right.
particular signature. And then they said, we need to figure out where this 6-carbon PFAS is that's coming from, that they saw as another significant signature in blood.
Gary?
Fundamentally, I mean the exposure routes are I think it's pretty well documented through ingestion, the food you eat, the water you drink, and the air that you breathe, where they're seeing, you know, higher levels in the populations in and around manufacturing plants,
Yeah.
where you have direct impact on the environment. But that's not to say that these things are persistent, and they do travel. And then there's atmospheric deposition, or they've been incorporated into so many different consumer products that it's very difficult to escape. And as a result, you know, you're finding a lot of PFAS in the population. And this is really what drove a lot of the interest in the early to mid 1990s. Is this had a real impact on our quality of life. My eggs didn't stick to my pan, but in the 90s, when they started to realize that, you know what, Houston, we got a problem. We're finding PFAS in serum levels of PFAS in the blood of you know, most of the population. That's a little bit disconcerting.
Yeah. Agreed. And I think you see this compounding problem of, you know, if it's in the drinking water and it's being ingested, and then it's getting into biosolids and then being land applied, and you just see it building, right? And yeah, and I don't think there is a definitive answer on that. I think it is regionalized. You know, based on where the regulatory framework is today, I would suggest that probably, you know, drinking water is the area of greatest concern. Therefore, the greatest amount of focus and investment, obviously, in treatment technology to make sure that that's being stripped out. So that's just my opinion. I don't have anything to reference, but my opinion as well. The last question we have right now, we're running short on time. This is an interesting one. It's a follow-up to what we were just talking about. But is there a way to get PFAS out of your blood? How do you get rid of it? Can you?
I'm going to say natural attenuation.
Yeah.
It's basically it's there, it's persistent. You know, are they forever chemicals? Never say forever. They do have a half-life in people, in the body, and this half-life, you know, it ranges from like 3 to 10 years, depending on the size, the molecular weight, the chemical and you know, physiological behavior of these compounds in people. So
Right.
when I say natural attenuation, well, you just got to wait. So if you've got a concentration, say of 10 nanograms per mil of PFOA, perfluorooctanoic acid, in your blood, and the half-life for PFOA is somewhere between 2.5 and 3.5 years, then 3 years, let's say. 3 years down the road, assuming you don't ingest any more PFAS, you got to turn the tap off. Mm-hmm. 3 years down the road, you'll have 5 nanograms per liter. 3 years after that, you'll have 2.5 nanograms per liter. So over time, you'll start to see a reduction. And they have seen this in compounds like the polychlorinated dibenzoyl dioxins. I mean, it's a real problem before, but they're essentially banned. People are very cautious. There aren't any real naturally occurring dioxins, well, except for volcanoes and forest fires. But the fact is, they have seen a decline in serum levels of the PCDDs, polychlorinated benzoyl dioxins in people. And I suspect it'll be the same thing with PFAS, but we got to get on top of it.
Yeah. So, I mean, the short answer there is there isn't a way to get it out of your blood. It's in.
Not that I'm aware of. But...
Yeah, not that I'm aware of either. Steph, have you heard anything?
I have not, no.
Heather?
The only way that PFAS disappears from your blood is if it binds to another tissue or organ in your body. And if it's the liver, then as Terry said, the liver can process it with a half-life of, a few years to start removing it from your blood if you don't ingest any more PFAS.
Right. This is highly unlikely.
So don't eat and hold your breath.
Right.
Yeah, but then also if you are able to get the PFAS levels down in your blood, then your blood will start cleansing it out of all of the other organs and tissues where it's been stored. So, yeah, the process hopefully will work in reverse to eventually get human blood serum loads down.
Thanks for that. That's great. I wasn't aware of that. That's great explanation. So we're running short on time. We're out of time. I'd like to take this opportunity to thank the participants, the people that are watching, for submitting their questions, and of course, our esteemed panel. Thank you, Terry. Thank you, Heather. Thank you, Stephanie. I think it was a great session. I really enjoyed it. Very insightful. And if you want to reference this session in the future, we'll also have this posted on our YouTube channel. Please have a look. And we will be the questions that we didn't answer, we will answer, and we'll make sure that those are available on demand as well. Additional information on our PFAS services is available at bvna.com, or you can contact Stephanie Paulin at stephanie.paulin@bureauveritas.com. And lastly, shameless plug for you, Terry. Don't forget to join us for our next webinar, where Terry presents on PFAS, TOPS and TOF, the differences and when to use. He gave you a summary of it today, but it's a great presentation. You don't want to miss that one. So thanks, everybody. We'll see you again.
Thanks, Quinn.